So here in lesson 87, just starting out with one other example here. As a reminder, when you are doing these, you're finding the area between the curves, revolving that around, all right? And one of the keys is that you have to find the intersection point. So here you see kind of the cross section with the two functions. The intersections are at 0 and 1. If they're not easy to find, you just set the equations equal to each other and find them however you can. If you have a calculator, do it with the calculator. Use your intersect function, all right? It'll be faster if you've practiced using your calculator like you should. And that'll also avoid any little mistakes. This one is simple enough though. I mean, probably doing it by hand even is easier and faster. Okay? So just a reminder of how we do this. Another thing we have to do is figure out which one is the outer shell and which is the inner. Okay? So in this case, the outer shell is going to be that radical x. The inner part, we'll use yellow. The inner part here is our x squared. So when we set this up, our volume is pi times the integral from where to where?
0 to 1.
From 0 to 1 of the radical x squared minus x squared squared. And then it's just a matter of getting the integral, okay?
The maximum volume of this whole object is based on the outer shell, right?
The maximum volume that it could be would be if it were solid, yeah. So that would just be the outer shell. And then we're cutting out the inside. All right, so our volume is pi times x squared over 2 minus x to the 5th over 5. Evaluated from 0 to 1. Okay, you plug in 0, you get nothing, so it's pi times a half minus a 5th. Okay, so 5/10 minus 2/10 would be 3/10, so this is going to be 3/10 pi. Okay, so that's exactly how it was in our previous lesson. Okay. Here are some kind of different looking ones though. All right. This one presents us with an issue where we have two different functions that we've got to deal with. Notice here, we're going to revolve this y equals x squared plus 1 around the y-axis. Now, if we were revolving it around the x-axis, we could just deal with one big thing and it would kind of look like this. All right? But in this case, since we're revolving around the y-axis, we need to rewrite this in terms of y. So y minus 1 equals x squared. X is positive or negative. Since we're revolving it, we only need to deal with one of them.
It's positive, right?
So square root of y minus 1. Okay? However, we want to revolve the area under this all the way down to the x-axis around. Okay? And you can handle this one of two ways. Notice here on the bottom, I simply have this rectangular area that I'm going to revolve around. That's actually just going to give me a cylinder on the bottom. Okay? That's going to be a cylinder. Now, if you want, you could just use the formula for the volume of a cylinder. Okay? The radius of that cylinder is going to be 1. Right? And the height is also 1. Okay? So this bottom portion this bottom cylinder right here is going to have a volume of pi r squared h. Okay? Pi times 1 squared times 1. So the volume of that whole bottom part is just pi. Okay? The top is where it gets a little bit tricky. Okay? Now, even if that weren't a cylinder, we could do it with an integral. Okay? We could do it with an integral. We could do it as pi times the integral from 0 to 1 of, that's the line x equals 1, so it would just be 1 squared dy. Okay? That'll give you the same thing. Alright? So you could do it with the integral, or you could do it just using the formula for a cylinder. But the top half here is where we got to be careful. Okay? The top half, we're doing the area between the line x equals 1 and this parabola. Okay?
Isn't y equals 1?
No, x equals 1. Because it's that vertical line, x equals 1. So, for that integral, notice I'm going from 1 to 2. Okay? So I have the volume of the top equaling pi times the integral from 1 to 2 of the outer shell is x equals 1, right? So the outer shell is 1, and I square that, minus the inner shell. The inner shell is that square root of y minus 1. Okay? Does everyone understand how we set that up? What questions do we have?
So for when you have the square root of y minus 1, back when we were trying to isolate x, it doesn't matter if you choose a positive square root of y minus 1 or a negative square root of y minus 1?
Correct. Guys, why does it not matter back here whether we do positive or negative? Because we're squaring it. We square it right here, and we're revolving it around the axis, so we'll hit that other side anyways. Okay? So now we can simplify. Our volume is pi times the integral from 1 to 2 of the square undoes the square root, and I have a 1 minus negative 1, so those cancel, and I just have a negative y squared dy.
Wait, a 1 minus negative 1 does not become 2.
Wait.
That's the top one.
Oh wait, hang on. Yeah, 1 minus a negative 1. Yeah, 2 minus square root of y. That's y. Okay? dy. 2 minus y dy. Thanks. Okay? So that's what we're taking the integral of. Pi times 2y minus y squared over 2, evaluated from 1 to 2. Okay? So we have,
Is there any way we can find out like a formula for the whole thing? All being separated?
well, no, because you have different functions.
Okay.
You have different functions. Remember, the function has to be defined over the whole interval in order to take the integral of it. So our square root of y minus 1 is not defined between 0 and 1. So you can't do the integral on that
Alright.
part. Okay, so we have 4 here minus 4 over 2 is 2. Okay, minus 2 minus a half. So 2 minus 1.5 is just a half. So 1/2 pi units cubed. Okay?
We found the area of the ball.
So we found the area,
No,
or we found the volume of this thing. It looks like a cylinder that has a bowl cut out of the top.
Right. So we found the
Okay.
volume of the ball, or we found the bottom of the rest. Or the
We found the volume of the bottom,
Bottom side.
not the inside here. That's what we subtracted out when we did this minus square root of y minus 1 squared. Okay?
So we found the.
All right. Take a quick look at this. Take a few minutes and see what you can do with this one. All right, so you guys have had a little bit of time to look at this one. What's the outer shell on this one, guys?
25, square root of 25 minus x squared.
Yeah, the square root of 25 minus x squared. By the way, you should be able to come up with those on your own.
Yeah.
If I tell you that I've got a sphere that has a radius of 5, you should be able to tell me, okay, that means the circle that would make up that has an equation of x squared plus y squared equals 25. It's centered at the origin, the radius is 5, that's it, okay? So if I want just the top half, then I solve for y, and I get this r equals the square root of 25 minus x squared. Okay, do you guys all follow that?
Yeah.
That's something from back in Algebra 2 that you are expected to know. Okay? They don't expect you to be able to do all the conics, but definitely circles you should be able to handle. So you've got that as your outer shell. The inner function is what?
3.
Yeah, y equals 3. Okay? So we're doing the area between those two. So the outer one is the square root of 25 minus x squared, and I square that minus 3 squared. However, what am I integrating over? What do I need to do?
Find the intersections.
Find intersections. Okay?
Negative 4 and 4.
Find intersections. So yeah, it is negative 4 and 4.
Look at the graph.
This is where some thinking outside the box a little bit comes in handy. Typically we find intersections by setting the functions equal to each other. But because this is a sphere, I know the radius is 5 and I know this is 3, so this is a 3, 4, 5 right triangle. Okay? So when I'm integrating, I need to go from negative 4 over here to positive 4 to get the right range. Okay? Now, if you did set 3 equal to the square root of 25 minus x squared, you would get x is plus or minus 4. But don't forget to think.
Okay.
Okay? So we've got negative 4 to 4. And did anyone get an answer?
96 pi units cubed.
96 pi. Anyone else get that?
Drew,
Drew got that? Okay. So 25 minus x squared minus 9. So let's make that a 16 minus x squared. Integral from negative 4 to 4. And we got our pi here. Oh, almost forgot my pi. So pi times 16x minus x cubed over 3 from negative 4 to 4. By the way, we could have done 0 to 4 and just double it, right? This is an even function. So we could have just done 0 to 4 and double it. In fact, let's do that now. Save ourselves a little bit of work. 0 to 4, and we'll multiply this whole thing by 2. So 2 pi, if I plug in a 0, I get nothing. If I plug in a 4, I get 64 minus 64 over 3, which is 21 1/3.
know it's an even function because it has the same endpoint?
Well, because it's symmetrical across the y-axis.
You know, because it's
And if I plug in a negative x, it doesn't change anything.
okay, so you're bringing in a -4 and a 4, and then you see that they match.
Alright,
have the same result. So that's why.
We resend our answer.
our answer. We did some
If you bring in a -4, you get a 3. If you bring in a 4, you get also a 3. That's why they're.
Yeah. Yes. Yes. Alright, so 2 pi times 22 2/3. 45 1/3 pi.
It's too cold.
Okay, what'd you guys get? 91?
We got 96 because we
Oh.
we messed up. We did 64 over 3 is 18.
Oh.
Isn't it 42?
Hang on. My arithmetic's off. That's what I get for being sick for 4 days. My brain's still kind of waking back up. What is it? 40, yeah, 42 2/3 times 2, 85 1/3. And I wrote 20 again. 42 2/3, 85 1/3 pi. There we go. Okay.